Hi everyone, welcome to the Chapter 1 Section 2 video. Today we're talking about different types of data. So data classification. First, there's several vocabulary words to kind of sort like what kind of data that we have. So the first way to differentiate them is qualitative data, quantitative data. Qualitative just means that you don't have really any numbers involved. Usually you don't have numbers involved, but even if there are numbers, those numbers don't mean anything. So qualitative data usually consists of attributes, labels, or non-numerical entries. So this would be something like if I had asked, what's your favorite color? So a list of colors could be an example of qualitative data. One that's kind of weird is zip codes, because zip codes, they are technically numbers, or even area codes in a phone number. They are technically numbers. However, when you actually think about what they mean, the zip codes or area codes kind of describe like a geographical location. So it's really more of a label than it is a number. I like to think about it as like if I were to take the average zip code in South Florida or something like that. Yeah, you can find the average, but the average number wouldn't actually make sense. Because what am I going to find? Like, if the average ended up in like Weston or something, what would that mean? Is that like an average location? That doesn't really make sense. So that's why zip codes, things like that, even though they're numbers, they're still not considered quantitative, because quantitative is when we actually talk about numbers. So quantitative data are numerical measurements or counts. And even within quantitative data, we can separate those into two categories, either discrete or continuous. So discrete just means that most of the time you only have whole numbers. Continuous is when you're allowed fractions and decimals. And when I say that it can include fractions and decimals, it doesn't necessarily mean that your data set will necessarily have fractions and decimals in it. Like if I asked you, how old are you? Then you can say like, you're 18, you're 15, whatever. But the possibility of being like 15 and a half is still there. Or like I could technically be 17 and 3/4 years old. So because those make sense, those fractions actually make sense when we're talking about age, then that would still count as continuous, even though most of the time we only answer with like, oh, I'm 17, oh, I'm 18, whatever. Okay. But then when we talk about discrete, where we're like whole numbers only, that just means like if I were to ask like how many people attended, you can't have like 15 and a half people who attend something, because how would you have half a person? So that's why that's something that would be discrete. Okay. Another way to talk about data is the level of measurement. So when we're actually asking survey questions or collecting data, the different levels or the different ways that we can measure the data that we get, there are 4 different types: nominal, ordinal, interval, and ratio. So we'll start with the least numeric, the least specific, is called nominal. So nominal only includes qualitative data, so no numbers. Okay, so that means we can categorize like with names, labels, or qualities, or like characteristics. Specifically, even if you have numbers like kind of like our zip codes, no mathematical computations can be made. So examples of this would be like if I asked for your favorite colors, if I asked for your favorite TV show, stuff like that. Things where you don't have numbers involved is the easiest way to talk about nominal. Okay, the next level is the ordinal level of measurement. So at the ordinal level, you can include either qualitative or quantitative data. The easiest way to remember ordinal is that the data can be arranged in order. So there's some sort of order to it, or you can do some sort of like ranking system with it. But differences in data entries is not meaningful. So this could be something like if I asked for your top three colors, top 3 TV shows, whatever. So because you can rank them, then there's some sort of order to it, but between like your first and your third favorite, whatever, you can't actually quantify like how much more you like one thing versus the other. Another example could be stuff like if I asked on how awake do you feel right now? Not awake, kind of sleepy, somewhat sleepy, fully awake. So that scale right there can be ordered, but there's not really any meaningful differences between each of those choices. Another example would be something like movie ratings, where we give it like 2 thumbs up or whatever versus 1 thumb up, I don't know. But that's another example of an ordinal level of measurement. Okay, the next most specific one is called the interval level of measurement. So now that we're at the interval level, we only deal with quantitative data now. The data can be ordered because you have numbers, so you can put numbers in order. Now, differences between data entries are meaningful because with numbers we can actually like find the difference between one or the other. And the most, or between interval and the next one, ratio, they're kind of similar, but what makes them different than each other is that in the interval level of measurement, 0 represents a position on a scale. In other words, like you could have negative numbers. Okay, so examples of this would be like temperature. Because we can say, obviously, temperatures are in numbers, so these are quantitative things. But we can also say, like, when it's really cold out, it's like -5 degrees or something like that. Or it's 0 degrees. And so 0 here doesn't mean that there's like a lack of temperature. It just means that it's just on a scale somewhere. Another example are years. Like this year is 2020 or something like that, or 1795, those types of years. We can even go all the way back in time to like 200 BC or something like that. So at year 0, that's still like a thing. That was still a time period. It doesn't mean that there was no time involved. So ratio then is pretty much like interval, except that 0 represents like not having anything. like none. So an example of this is like if I was asking about like height. So if you had a height of 0, that means you were 0 inches tall, you have nothing. You're like, you don't exist because there's nothing there. Or if we talk about time in terms of like minutes or seconds, then we can say like if I took 0 minutes to do homework, then that means I didn't do any homework at all, so none. So for the ratio level, 0 has to represent none. You can also think about it as a ratio, because it's called a ratio level of measurement. A ratio of 2 values can be formed. What I mean by this is I can say something like, I took twice as long to do something, or I'm twice as tall as this other person, something like that, where you can say, like, if I multiplied my height or something, or halved my amount of time or something, halved my weight, then I could compare that with somebody meaningfully. So I'm going to write that down as data can be expressed as a multiple of another. So kind of like 1 minute versus 2 minutes is the same as like twice as long. Okay, so those are our different levels of measurement for how to quantify data. I included this nice little chart here, so there's nothing to write down here, but it kind of helps me put into perspective, like to compare and contrast each of the different levels, because at the nominal level, you can put it in categories, but then you can't do anything else. At the ordinal level, you can put it into categories and you can put the data in order, but you can't do anything else. At the interval level, you can put things in categories, you can put things in order, you can subtract data values because it's like a scale kind of, but you can't see if one data value is a multiple of another. And then that last one, the ratio, you can do all 4. So just a nice little visual for how to compare each of them. But otherwise, that's it for this section. So hope you understood the different vocabulary words here. Thanks for watching. Bye.